Oracle DB2 SQL Server, MS SQL. Even in Teradata, the SQL, all of them follow ANSI standards. Nothing different from the semantics perspective.
All SQL standards, and then on top of it has their own DAX.
Yes. And it runs on a single or a multiple node. I'll explain you what a single node and a multiple node means in the coming slides. And basically, Teradata database, it's a database server, and it uses parallelism component, parallelism feature basically to manage terabytes of data. And it is capable of supporting concurrently multiple users from various client platforms using massive parallel processing architecture. We see the Teradata architecture as MPP architecture, massive parallel processing architecture.
Okay. So what is the exact meaning of MPP, the massive parallel processing?
Like more number of nodes performing the operations in a parallel way. Massive. More amount of processing than in a parallel way. That's why massive parallel processing.
Okay. So here you say concurrent users from various client applications means what are the various type of client applications?
It can be like SQL Assistant, BTEC, or any utilities which are run on Teradata. It can be a mainframe client, it can be a Windows client, it can be a Linux client.
Or Unix also, right?
Yeah, Unix as well.
Okay.
And this is a little bit history of Teradata. It started way back in 1975, and they released their first product in 1979, V1R1, basically version 1, release 1. It has undergone many changes in the coming years, and some of the major releases happened, like I am aware of, is from V2R5, basically Teradata V2R5, where some of the major features got introduced into that particular product. And then in 2005 V2R6, then TD12, TD13, and then TD14. It's already given to the customers.
TD14 version?
TD14, yeah.
Okay.
This was an old slide, so that's why ongoing development. But yeah, it has been released to the customers as well now. TD14 is being run at the client space now. So from the
user, it got released version, the TD14.
TD14 last 2012 in the last quarter.
Okay, 2012 the last quarter. Okay, sounds good.
It's 8 months back, around 8 to 9 months back. And from most of the customers, right, currently will be running on TD12 and TD13 mostly. TD12, TD13, and TD13.10. If you look at the banks, right, most of the banks will be running on TD12 or TD13. They will be upgrading very late actually to TD14. And if you look at some of the retail clients like Amazon, Groupon, Snapdeal, and these kind of customers have been upgraded to just TD14, and then majority of the versions are still TD13. So mostly if you are into any client place, right, if you are into any job, you might be working on TD12, TD13 or TD13.10, a higher version of 13 release. And from the user perspective, right, there will not be much difference because the syntax, semantics, and everything will be same. Only thing is from the performance perspective of the system, or some additional features being added. Some features might not work properly in the previous release, so they might be upgraded in the higher version. That's the only difference we have from release to release. So from the user perspective, it's nothing much difference. Very slight difference will be there unless and until a new feature got introduced, which deals with a new syntax.
Okay.
Like scalar subquery is there. This is a new feature. So a query which is of scalar subquery will not work in TD12. It will not support that syntax. Whereas in TD13 it will work. Similarly, no PI. No PI is a feature which is related to a new syntax. So those kind of queries will not work in the previous release. Those are the only slight differences from release to release. Apart from that, everything will be same.
Okay. So you will cover all these things in later slides, sir. What is query rewrite, scalar subquery?
Yeah, when we come to the practical classes, right? There we will be dealing with the feature and then the syntax and semantics. of that particular feature.
Okay, good.
Query rewrite scalar subquery OPI temporal feature. One more feature is a columnar feature. We'll even look into that. Columnar.
Okay.
You might be heard about it. Some new databases like Vertica. It's a columnar database.
I haven't heard about it.
Okay. It's a new, good feature, which is coming, which is the upcoming feature in the market. So they even incorporated that in the TD14 release. So we will, I might not be able to show you the syntax and that, but a good overview of the feature, how that feature will be helpful.
Yeah, that will be good enough.
Yeah. Okay. And this is a slide which talks about the architecture of Teradata and some of the internal components of Teradata. If you see the gray color box, right? This can be considered as a node. A node is nothing but a machine where we install Teradata. My laptop can be considered as a node if I install Teradata in that. So this is a single node.
Okay.
Okay. And in the earlier slide we said, right, Teradata runs on a single or a multiple node. So multiple node, more than one node. Similar kind of a node, more than one. We say it's a multi-node. So I can install Teradata in my system and I can install Teradata in another system, but I can configure both the systems into a single system.
Okay. So this is a single system with multiple nodes. Since we have 4 AMPs, that's we call
it. This is a single node itself. This is a single node itself. A single node having one parsing engine and 4 amps. Multi-node means similar node, more than one. So again in that node, again I will have parsing engine and access module process.
Okay.
Now in the single node, right, the major components are parsing engine, then message passing layer, and then access module processor. Parsing engine is nothing but it's a software component and it processes the request and checks the syntax and semantics and tries to optimize the request as well if it is possible, and then distributes the data across the amps. That is the functionality of parsing engine. Take the request, do the request processing, check the syntax and semantics, optimize the request if possible, and then if it needs to insert the data, then it will distribute the data and then insert across all the apps. Here in this example, the client is trying to insert around 12 records into a single table. So the parsing engine, what it is doing is it is distributing the data across the amps. That means all the 12 records are not stored at one place. They are distributed across the amps. So a single table is divided across multiple amps so that each amp is storing a subset of the table. Not the complete table but a subset of the table. So here,
Vardhan, who will decide how many amps and how many disks are in the particular node?
When we are installing Teradata, right, you have a brand new system, and if you are installing Teradata, right, then at the time of configuration, right, when you are running that some scripts, right, so that the base Teradata patch will be installed. At that time, you will configure actually in that particular node how many parsing engines and how many amps you want.
Oh, even we can have more than one parsing engine within the same node?
Yeah, same node we can have more than one parsing engine.
Oh, okay.
So at the time of configuration, when we install Teradata, at the time of configuration, we will decide how many parsing engine and how many amps.
Okay. Amps and the disk are there 1-to-1, right?
Yeah, each amp will be associated with one virtual disk. Virtual disk is nothing but a collection of physical disks.
Okay.
This is a collection of physical disks, multiple physical disks. So each amp is associated with one virtual disk.
Okay.
And here, as I said, the client is trying to insert an n number of records into a table. But what happens, the parsing engine will distribute the data across the amp. And basically the distribution mainly depends upon the primary index value. Primary index is a 1, which decides the distribution. We will see what are the algorithms involved in that distribution mechanism, how exactly each and every row will get distributed across the AMPs in the distribution mechanism class.
Okay.
Storage and retrieval of data. That is a class where at a later stage we will see exactly how each and every record is being distributed. What are the additional parameters while we are storing the data, what we have. Currently for timing you assume that okay, Teradata tries to distribute the data across the AMPs and in an even fashion. Some criteria are there so that the distribution should be even. That means the data should be unique in nature. Then the distribution will be in an even fashion. Suppose if I take an employee table and employee number is chosen as the primary key, primary index, then the distribution will be even. Or if I choose a department column, then skewness can be there. Suppose if I have a table with 150 employees and out of that 140 employees belong to department number 10 and the remaining 10 employees belong to other 3 departments. Then what happens if I choose a department number as the primary index? Then all the 140 records will go to one AMP where it all belongs to single department.
But in that case that is not evenly distributed, right?
Yeah, because of the primary index value. Why? How we choose the primary index? Based on that the distribution will be there. If we choose a column which is more unique in nature, then the distribution will happen in an even fashion. By general.
Yep.
Okay. Now in this case, the distribution has happened. Right now, if you run any request on top of this table, assume select star from table T1. This is the table T1. Then what happens is parsing engine will take that request. Then message passing layer is a communication layer, communication protocol, which communicates between parsing engine and AMPs. So what it does is that request will be broadcasted to all the AMPs. So each AMP will be having that request, select star from T1, select star from T1, select star from T1, and select star from T1.
Okay.
So each and every AMP will be running the task in a parallel fashion. That's how parallelism works in Teradata. Suppose if multiple users are there, okay, parsing engine can support multiple requests parallelly. If I am the user submitting a request and you are the user submitting a request and only one parsing engine is there, yeah, still that parsing engine can take both the requests in a parallel fashion. It can support 120 sessions parallelly.
Okay. So same table can be accessed by 127 parallelly.
If at all 120 users are there, right?
Yep.
A single parsing engine can handle that capacity.
Okay. The message layer is only specific to this particular node, or it can communicate with some other node also?
It can communicate with other nodes as well. For a single node, right? For a single node, the Ethernet, the Binet device driver software will be there. A Teradata device driver software that will be sufficient to handle the communication within the node. But if it is one more node is there, suppose, assume. So what happens is a node-to-node communication should happen. In that case, we will have the message passing layer as a chipset board. An external chipset board need to be connected to both the systems so that node-to-node communication happens. Suppose if this parsing engine needs to communicate with an AMP which is in the other node, then what happens is that communication happens via the chipset board.
Okay, got it.
Just show you. This is one. Now this is node 0. The 4 nodes are there, and here you can see the chipset board. This is the chipset board 1 and chipset board 2. So if this parsing engine wants to communicate across all this 32 amps, even this chipset board is not there, the device driver software will be sufficient to handle the communication between this parsing engine and the 8 amps. But for the other 24 amps, it needs an external chipset board so that it passes the communication to other apps in the other nodes.
Okay.
So this is again part of MPA. This is again part of message passing layer.
And one they're part of the message passing layer.
Come again?
No, the BINET 0 and 1, they are actually part of the BINET, right?
Yeah. MPL. They are part of MPL, message passing layer.
Yeah, message passing layer. What is the difference between message passing layer and BINET? Are they synonyms or?
No. BINET, message passing layer, consists of two components. One is BINET and one is PD, parallel database extension.
Okay.
So for a single node, right, we don't require a chipset board, but a device driver software, which we say again a BINET, boardless BINET we say, because we don't need any external chipset board. A boardless BINET software is sufficient. But if it's a multi-node, we need to have an external hardware kind of mechanism, a chipset board, so that it can handle the communication across the nodes. So message passing layer components are BINET and PD, parallel database extension.
Okay. And in a real time, how many nodes will be there, and approximately? Take any Bank of America, Chase Bank, or Amazon.
Bank of America has around 100 nodes.
Oh, all 100 nodes are interconnected?
Yeah, they are connected by a chipset board.
Okay.
And Walmart will be having around 700 to 800 nodes.
Oh my God.
That's the biggest one, I guess. Walmart is the biggest one.
Okay.
Capacity perspective.
Okay. So is there any upper limit for them? How many nodes can be?
Earlier it was 1000K. 1000 nodes is the maximum. Now they have extended to 4000.
Oh, okay. Great.
And similarly, each node also has some limits basically. Like it can have combination of 128. We call it as a VPROC, parsing engine, VPROC or AMP VPROC, virtual processor. It's a software component. So we name it as a VPROC. And a node can have maximum 128 VPROCs. Any combination. I can have 32 parsing engines and 96 amps, or 64 parsing engines and 64 amps. I can have any combination of that. I can have one parsing engine and 127 amps, anything. But collectively 128 VPROCs.
So these two are part of parsing engine and amps are part of the together 127 is the maximum.
Yes.
Okay. How about the disk? Don't we count a disk, local disk?
No.
Okay. But there will be only one message passing there for if we have
message passing layer is nothing but just it's a BINET and PD.
Okay.
So this is how parsing engine handles the sessions in a parallel way. Message passing layer, again this component handles the sessions request or communication request in a parallel fashion. AMP, all the amps perform the operations in a parallel fashion. Similarly, within the AMP, each AMP can handle 80 tasks parallelly. So each AMP, the 80 tasks can run in a parallel fashion.
Okay.
Suppose, assume this is table T1. Similarly, you have one more table T2, again which is distributed across all the amps, isn't it? Now, if I run a request like select star from T1 and you run a request from select star from T2, what happens? Parsing engine will take both the requests parallelly, passes to the message passing layer and broadcast it to all the amps parallelly. So each amp is having how many tasks now? 2 tasks. One is mine and one is yours. So totally 4 tasks. Each amp is having 2 tasks. So totally 8 tasks per amp, 2 tasks. So both the tasks will be running parallelly within the amp, and across all the amps perform the task in a parallel fashion. So top to bottom at each and every component, parallelism has been there. That feature has been implemented in a very defined manner.
Okay.
So that's why in Teradata, parallelism is the key feature basically. It's heart of Teradata, parallelism. To handle multiple tasks in a parallel fashion. Any questions?
Yeah, it's very clear about that. Yeah, it's very clear. Yeah, I have gone through these slides earlier, so that's why it's easy for me to understand.
Fine. And yeah, Teradata terabyte, we say it's 10 power 12, 1000 GB. 1000 GB is 1 terabyte. And these are some of the common differences between Teradata and other RDBMS. Most of them, even now, Oracle, if you look at Oracle, they have come up with a system called Exadata. Oracle Exadata, Netisa is there. So even those RDBMS are somewhat now getting converted to a data warehousing domain, and then trying to implement some of the features already implemented in Teradata, like unconditional parallelism and distribution mechanism kind of stuff. So some of the features, some of the differences might be outdated, but the major difference is this one: shared nothing architecture. Shared nothing architecture is a major difference. If someone asks you what is the difference between Teradata and other RDBMS, then you can say Teradata is a shared nothing architecture. Why? Because here this particular disk data, right, it is shared only to AMP1. This disk data is never shared across any other AMP. It can't be processed by other AMPs. It is only being processed by AMP1. So this is not shared across the AMPs. That's why we say it is a shared nothing architecture. Never share the data across the AMPs.
What if the AMP1 is let's say disabled or not accessible for a period of time? So how can you access the data in AMP1?
There are certain mechanisms basically, like maintaining the data in a fallback manner, so that even if an AMP fails, still we can retrieve the data from other AMPs.
Okay.
Maintaining duplicate copy. There are some standards mechanisms, and we will look into that in production mechanism feature.
Okay.
And the rest all are individual to Teradata, basically like unconditional parallelism, designed for decision support system and data warehousing. Because it's an enterprise-wide data warehousing solution, only for data warehouse. Supports terabytes of data, index used for storage and fast retrieval. It's a better storage. Why we are seeing a very good distribution of data is because of a better storage, and that is possible because of an index, primary index basically. And then can handle billions of rows.
Vardhan, what is unconditional parallelism?
Like we are not defining parallelism to be conditional. Under these conditions there should be parallelism, and under these conditions it should not. We are not defining any conditions. It's not rule based.
So in Teradata, it's parallelism is inbuilt. So you don't specify anything.
Yeah. We don't specify any conditions. Yeah, that's true.
Okay. How can I compare with Oracle? So in Oracle parallelism, do I need to say explicitly?
In Oracle, like based on some of it, because most of the underlying rules, right, in Oracle and other system, they are rule based basically. If this is the case, this is the case, then perform this way. If this is the case, this is the case, then perform this. Teradata is not like that. It's a cost based approach. Same request can run in different manner depending upon the configuration of the system. Same request, same data, but can run in different formats based upon the configuration of the system. But in Oracle, if it's a rule based, right, irrespective of the configuration of the system and data, it will run in one fashion.
So Oracle has both, right? Rule based and cost based.
Cost based, yes.
Yeah, I think recent versions they converted into cost based. I think.
Yeah, cost based. Yes. Earlier, most of the systems were only rule based, but Teradata and Netisa, they were completely from the cost based perspective. So now even the other RDBMS, like mostly Oracle DB2, what they are trying to come up is convert the rule based into some of the cost based rules, cost based approaches. So
what is Netisa is another data warehouse?
Yeah, Netisa is another data warehouse built by IBM.
It's IBM Netisa. Okay.
It was an individual company basically, Netisa, but has been acquired by IBM. Now we say it's an IBM Netisa. And yeah, from a capacity perspective, it can store billions of records and billions of data and process millions of instructions per second. That's the capacity of Teradata RDBMS. And the parallel processing, that is the one which makes Teradata RDBMS faster than any other relational systems currently in the market. And the single data store, where it can be accessed by network attached clients and channel data systems. What does this means? Network attached means all these Linux, Windows, Solaris, Unix, all this comes under the network attached environment, TCP/IP. And mainframe is the one which we call as a channel attached system. So Teradata can be accessed by both network attached systems as well as channel attached systems.
Okay.
And fault tolerance is like it can automatically detect and recover from some of the failures, some of the hardware and software failures. And data integrity, yeah, we can ensure that the transactions are either complete or roll back to a stable state if at all any failure occurs. So we can ensure data integrity is there. And scalable growth, yeah, we can allow the expansion of the system without sacrificing the performance. Like suppose currently this is my business and a very small business I am running. So this configuration is sufficient for me. One parsing engine and 4 amps are currently sufficient for me. Now what happens later after 6 months my business got expanded and this is not sufficient for me.
Okay.
So that what happens is the performance will be linearly scalable. So if I have one more node, right, with same configuration, what will happen? The performance will be doubled. Why? Because we are distributing the load across 2 nodes now.
Yeah.
And we are doubling the processing capability.
So that will not no need to change any code or no query change, nothing, right?
Query, no. What happens is when when we add additional nodes, right? At there will be a shutdown period basically when there will be some downtime period. At that time, if one more node is added, right now what happens is earlier whatever the table data we have, they are being distributed across 4 amps. But now if I add one more node, right, with same configuration, what happens is the table data now should be distributed across 8 amps now. So a reconfiguration procedure will be there. Once additional nodes are added, a reconfiguration process will be run so that existing data will get redistributed across all the amps now.
Okay, but client perspective, for him it is same, right? So he doesn't know how many amps are there, how many nodes are there. So
it doesn't.
Okay. Yeah.
And SQL is the structured query language where we can access Teradata servers. So this is a little bit overview of Teradata introduction basically. And if you look at the contents, right, what all we will be discussing in this training module basically. This is designed mostly from the development perspective.
Okay.
And, this is the architecture and some internal components in depth actually exactly what from you asked me like what is the maximum limit of a node, how many nodes I can. So some statistics and then some internal some more modules, parsing engine and sub modules, what all sub modules it has, what all sub components it has, those things. Those things we'll be looking in the architecture and the components perspective. Then recovery and protection mechanism, how the data is protected, how the system is protected. A few technical concepts as well. Okay. Then complete technical concepts, the index mechanisms, how they are implemented, how they are created. Primary index, secondary index, join index, hash index, those things. How the data is exactly stored. How the data is exactly stored and how the data is exactly retrieved. How efficiently we need to frame sequence in order to retrieve the data in an efficient manner, those things. Then a little bit introduction on the DDLs, DMLs, DCLs, and then some statements and some conversion, naming conversions, aliases, those things. Different clauses of select statement, update, insert, delete. What's the syntax and the semantics, and what are the different clauses we have. Then comes the basic string functions, arithmetic and logical functions and operators, conditional statements, set operations, those things. and this, and then comes to the joins. What are the different join types we have in Teradata? What are the different join strategies we have? Then little bit on performance tuning. Performance tuning we will come at a later stage. Then what are the different strategies and join types and how they are exactly performed. Yeah, Madhu, just be on online. I'll be back in 1 minute. Here we will be having an overview of all the join types, join strategies, on how exactly they are being performed internally. When you look at an explain plan, how to generally understand what is exactly happening, what is the difference. Can we modify that query a little bit so that the explain might look different, so that it might go for an efficient plan. So, and this these are additional commands: the help command, the show, explain. Explain is the one which I was talking about. Looking at the explain and see what is exactly happening, how to understand that text. Then the collect statistics, which collects the information, demographic information on the table, and pros and cons. If we have, what will happen? If we don't have, what will happen? Those things.
Okay.
And again, technical. What are the different objects we have in Teradata? How they can be implemented? How can they be created and how they can be handled? And then a little bit on admin. Okay, this comes the admin part. So that in order to practice right on our demo version, so we'll be looking at a little bit on admin part as well. How to create a permanent space, how to manage the databases, how to manage the user, how to create tables and objects, and how to grant access to them, how to revoke the access to them. A little bit of admin part.
Okay.
Not required from the developer perspective, but in order to implement these, right, we need a little bit of this. If I want to create some objects, right, I need to have some access, right? I need to have a user, I need to have a database. For that sake, we will be learning this as well. Simple topic, not that difficult. And then various type of transaction modes, how they can be executed in Teradata, those things. Then the differences between the transactions from one mode to other mode, those things. And then performance tuning, some of the best practices which need to be followed when we are writing SQLs. A SQL can be written in multiple ways, but one will be more efficient than the other. So how to know that? What are the standards we need to follow? So there are certain general standards. Either you write in Oracle or SQL Server DB2 anyway. Some standards are there. Apart from that, from Teradata architecture perspective, what we need to follow. And then comes the utilities part, the production support roles, like doing the load and unload of jobs, load the data to the system, then extract the data from system to flat file. Then what are the different mechanisms? Basically, there are 4 tools and one GUI based tool, TPT, fast load, multi-load, TPUM, fast export, and TPT. Then BTEC.
What is TPT? What is TPT version?
Teradata Parallel Transporter.
Okay, Teradata Parallel. These are all client tools?
Client tools. Client tools. Teradata client tools. TPT is there from TD13 onwards. Earlier it was not there. Earlier only script based was first. TPT is little bit a GUI based. Drag and directly we can specify some values. It will generate the script for performing the job. Whereas for this, right, we need to explicitly write a script.
Okay.
10 to 12 lines of script we need to write. Then once we are done with this, we will be looking at some of the features, like as I said, no PI, scalar subquery, temporal, columnar, and a little bit for this syntax is there. For this I need to fetch the syntax and those things from the SQL perspective, how we can implement that. Theory perspective I will be explaining you. By the time if I am able to get some data stuff on the syntax as well, I can go into that as well. Or else, once it is full-fledged available to the outside world, right, we can have a syntax for that as well. And then from certifications, I will be providing some dumps and a questionnaire for the data basics and SQL for TD12 version. If you are planning for certification, you can even, once the training is done, you can even go for that certification as well.
Oh yeah, great.
Apart from that, like this is the general training content actually which has been designed. Apart from that, like most of the people who come for training, right, they will be, most of them are US actually, they will be working for some clients. So some are working with on Teradata environment as well. So on the, some topics might not be there, which I might have missed it or not covered here, which might be useful for them. So if at all while you are taking the training, if you come across any topic which is important to you and it has not been mentioned here, even after the training I can discuss it, or if it's very important or urgent, I can cover within the training period.
So sounds great.
Any questions and doubts you have? And
yeah, I mean,
I have we will be working on TD13 environment on my system. My system is having TD13 Windows. But if you want to practice it at your end, right, you can install Teradata 13 Linux version, free one, not a trial one. It's a free version, demo version, available in Teradata website, Teradata Linux 13.10.
But I don't have Linux install on my.
No. You on Windows itself, you can install a VM on a Windows environment. You can install a Linux VM. The package is a Linux VM package available in Teradata. So no installation, nothing. Directly download that package and open with a VMware player. That's it.
Okay.
You will
So that will be.
go and you will enter into a Linux Teradata installed package. Teradata installed on a Linux OS. We'll go into that environment directly.
Yeah, that will be useful, right? Even in a lot of the productions, people will install on Unix or Linux rather than Windows. So
yeah,
that I will get more exposure
practice for you. Yeah.
Okay. Really nice. Okay.
And from timing perspective, what's the current time at your end?
So right now it is 11:45 for me. So I think
11:45 for you, and it's 5:45 for me.
Yeah.
So totally 6 hours difference, right?
Yep, that's correct.
Yeah, exactly 6 hours different. So when you'll be back from office, really?
Usually my office hours are morning 8 to 5, 8 to 6 around. So even I can work from home also. I have that facility. So whenever you have time, just you tell me. I will definitely adjust my timings here.
And if you have any other questions, you can let me know.
Okay, Surendra, he will schedule the timings, or I can.
Yeah, he will share. No, he will schedule the timings.
Okay.
Yeah, you can talk with him. I will also have a word with him. And, if you have any other queries, you can let him know.
Okay. Yeah. And then that sounds good. For timing.
Okay.
Yeah, maybe tomorrow we can go for. I mean, if you have time, we can go for another 1-2 hours extra.
Yeah,
Saturday.
Sure.
Okay.
Yeah.
So my time. Yeah, for you it will be around afternoon, maybe around 3 o'clock. Means for me it's morning 9 o'clock. So for you from afternoon 3 to any time, 3 to till whatever you are comfortable.
Okay, fine, definitely.
So that way for me morning 9 o'clock, and from 9 to I will be fresh minded. So I can grasp as much as I can definitely.
Sure.
Okay.
Okay, fine.
Okay. Yeah. Thanks. Thanks a lot for that.
Thanks, Madhu. Yeah, nice talking to you.
Yeah. Sure. We'll see you tomorrow.
Sure. Thank you.
Yeah. Thank you.
Bye.
Bye.